guys, today we are going to do 5.1 polynomial functions, and our objectives. I will be able to classify polynomials, and I will be able to graph polynomial functions and describe end behavior. So some vocabulary. First, a monomial is one term, and it's either a number, a variable, or a product of a real number and or one or more variables with whole number exponents. So that is key there. We need our monomials to have whole number exponents. Then the degree of the monomial in one variable is the exponent of the variable. So the degree is the exponent of our variable. Polynomial is a monomial or a sum of monomials. So adding or subtracting monomials gives us a polynomial. And the degree of the polynomial in one variable is the greatest degree among its monomial terms. So the highest exponent in all of the monomials will give us the degree of the polynomial. Then with a polynomial with the variable x defines a polynomial function of x. So now we have polynomial functions. And the degree of the polynomial function is the same as the degree of the polynomial, which would just be the highest exponent. So, the standard form of a polynomial. We have our terms arranged by degree in descending numerical order. So, our degrees of each term goes from highest to lowest. And the example on the bottom shows that we have our highest degree of 4x cubed plus 3x squared plus 5x minus 2, where we have a cubic term, a quadratic term, a linear term, and a constant term, referring to the exponents of that term. We can also classify polynomials by its degree or its number of terms. So polynomials of degrees 0 through 5 have specific names, as we see in this table right here. We should be familiar with monomial, binomial, trinomial, and now polynomial as well. Constant has a degree of 0. Linear is degree of 1. Quadratic, which we just finished, is degree of 2. And that's when everything was squared. Cubic is degree of 3. Quartic is degree of 4, and quintic is degree of 5. So we can classify polynomials. So we're first going to write each polynomial in standard form. What is the classification of each polynomial by degree and by number of terms? So we have 3x plus 9x squared plus 5x. I'm going to write this with my exponents in descending order. So 9x squared plus 3x plus 5. The polynomial has a degree of 2. Because that's the highest exponent, and it's 3 terms. So this is also called a quadratic. Sorry, I don't know why it's frozen. Sorry for those technical difficulties. But since we have a degree of 2, it is a quadratic trinomial. Because we have 3 terms. You guys go ahead and try B on your own. So, the degree of the polynomial function affects the shape of its graph and determines the maximum number of turning points, or places where the graph changes direction. It is It also affects the end behavior, or the directions of the graph to the far left and to the far right. This table on our right shows you examples of polynomial functions and the 4 types of end behavior. The table also shows intervals where functions are increasing and decreasing. The function is increasing when the y values increase as the x values increase, and the function is decreasing when the y values decrease as the x values increase. So if you look at our 4 examples, we could have end behavior of both of our ends going up, both of our ends going down, one starting down and ending up, or one starting going up and ending down. You can determine the end behavior of a polynomial function of degree n from the leading term ax to the n power of the standard form. So, if a is positive, or the coefficient is positive or negative, and if n, the exponent, is even or odd, will tell us our end behavior for the left and right side of our graph. So, in general, the graph of the polynomial function of degree n, where n is greater than 1, has at most n minus 1 turning points. The graph of the polynomial function of odd degree has even number of turning points, and the graph of a polynomial function of even degree has an odd number of turning points. So consider your leading term of each polynomial function. We are going to determine what the end behavior of the graph is, and we are going to check our answer with a graphing calculator. So 4x cubed minus 3x, we have our leading term is 4x cubed. Our coefficient is positive, and our exponent is odd. So if we go back to our table, if our coefficient is positive and our exponent is odd, we will then be starting down and ending up. So we will be starting down, doing something in the middle, and ending up. In order to say this, we would say as x approaches negative infinity, so as we're going to the left, our function f of x is approaching negative infinity because it's going down. And as x approaches positive infinity, or as we're going to the right, f of x is approaching positive infinity. You guys try the next one on your own. Okay, we are going to graph a cubic function. So we want to, in order to do this, we are going to make a table of values. We have y is equal to 1/2 x cubed. When you have a cubic function, it's easiest to make a table from -2 to 2. And we know once you plug in all the x values from -2 to 2, we get -2, -4, -1, 1/2, 0, 0, 1, 1/2, 2, 4. And we connect with arrows. So our end behavior is down and up. There are no turning points because we do not switch directions. We are always going positive. And the function increases from negative infinity to positive infinity. Because our y values as we go to the left are going towards negative infinity, and our y values as x is getting bigger is going to positive infinity. And that's it.